we go. All right. There we go. Okay, final. We have 5 more meetings and then that week of finals. And what I like to do is something that I have done for several years now. Most of us have finals in other classes, right? And then you take your final and you never know what you got on your final until the grade is posted. And then you have to extrapolate what you got on your final based on your final grade, right? I hate that. So what I do is get all the work in the week before, and then the final class during finals week, you come in, you check your grade, we arm wrestle. I have a survey for you because you know the grade. So now you can be brutally honest with the survey. So you don't have to worry about hurting my feelings. And the survey is really simple. It's just 3 questions. And that's how we end the class. So 5 more sessions. And that's the question tonight is, what are we going to be doing? Well, that's kind of what I've spent a lot of time working on the final. I'm going, that's too hard. Oh, that's too easy. Well, darn it. Let's ask the class. So that's kind of what I'm doing, because you're the highest class I've ever taught. So a lot of you folks are in your, hitting it. What do they call it? Hitting it out of the park. So that's a good thing. So, but it also requires me to change a few things around. So the typewriter program that we did with Csci, we started that last Tuesday. We played with it Thursday. This is what I would like to kind of roll in to the final. First of all, let's talk about, let's see. Let me minimize a few windows so I can find where I am here. Such fun problems I've been having. Okay, what I'm going to do, I'll just make a new directory here. I'm going to just call it, I'll call it lab 9 or homework 9, which is very well going to be the final. Maybe I'll do one other depending on how fast everybody gets done. We'll see. Now, some of you know this, which is fine. But I know there's several that are struggling with it. All right. This is written in C. Okay. And I'll simply just call this main.c just for the sake of argument here. What does it do? Well, let's do this. How many kind of absolutely know for sure what it is versus the people that are kind of, yeah, I recognize the term, but I'm not sure what it's doing. And then the other people are, I'm freaking clueless, which is totally fine. Oh, how many? It's a stub, so it's not complete. How many know what this is doing? Oh, good. The majority of you. That's good. Now, how many are going, yeah, I'm a little familiar with it, but I'm not quite sure. Okay. And then somebody else is, I don't know. I need to go to Csci to explain it to me. Okay. That's good. All right. This is a good thing. This is the argv argc in C that we did earlier, kind of, in class where we took scanf, where it would prompt from inside the program, take the user data, and spit it out. What this does is it got your program code, and then you have your parameters on the command line. Okay, so that's the argv argc idea. The idea is you take your command line parameters and you put them into the program. Okay. This works, and we can use it to generate our library code using -s to see it in our assembler, right? Now, we've been using NASM. Can we generate assembler for NASM? This is the little stuff. That little kind of thing is the stuff you need to put in your notes on your blog, because that's the kind of thing that can really help you in the job interview. It's those little things that are hard to remember because you don't use them all the time. Okay. But the answer is yes, we can generate NASM code from GCC. All right. So what I'm going to do is truncate some of this data here and turn this into a piece of code that we can use to analyze the assembler. And I'll use the same line over here. Now it's not the same. I'll give it a different name. Main, and we don't need the foo. And we'll just call it argy. Okay. And the standard C11, that doesn't really matter. Okay. But we do need our libraries. And we won't use this. So now that we have the complete program, I guess I'll change the name. Argy. Why not? Whoops. Yeah. So in essence, what this is doing is using argc and argv to get our command line for a single number. And it's using ATOI, which is part of this library. Oops, yeah, that library. That basically says ASCII to integer. Because when you use the command line, things are ASCII and you have to convert it to an integer or a string or a float. So yes, there's an ATOF, ATOS, and so on. And then it says your number is D for decimal, and it prints it. Okay. And here's the number that we save in. So we will go ahead and compile this, run it. Well, let's do it all at once. Let's just make the compile line run it for us, since this is pretty straightforward. And I'll put in 7. Oops. Gotta fix my comments. That'll work. Now, we want to generate some assembler. Now, going back into this book, as you work through chapters, 10, 11, and 12 is the pertinent stuff for this class. And it talks about adding the compiler directives so you don't get so much noise into your output. Okay. And so let's start with the easy one. So we say GCC, and this is how we get our NASM code, MASM equals Intel. And okay, and then we did the E. So what this is doing with the dash E is don't go all the way through, just kind of stop after you get the assembler. Okay. And what this does is if I do this, it just generates it to the screen, but I don't have any assembler file. If I wanted to get my assembler file, did I get that right? Oh, I don't need the G, that's for sure. And I don't need the output. Remember what this is for? 0, optimizations. We want 0 optimizations. So here's our assembler code. Clear as mud. There's that. Now, we've learned so far that we can take this and just link it, use GCC as the linker, and we'll create an executable, right? We've all done that. This isn't helping me learn how to use argv and argc in assembler, is it? That's an awful lot of noise. All right. So let's do, remember some of these others that we've added? Let's see. I want MASM Intel. FNO async. Now he's got it. This is just his convention. He puts all the flags before he puts it in. Doesn't really matter. Okay. Now this is one of the flags to cut back on our noise in our generated assembler. Whoops. Unwind. Would help if I could spell asynchronous. Whoops, created it. Whoops, didn't do the S. Why not? What I forgot. Oh. Of course it didn't do the S. I forgot the /S. You should have told me. You all know that. Oh, this looks a little more human readable, doesn't it? This is a little better now. Now we get the idea. It's called main, and we're looking at things, and this is all in. Is this 32-bit or 64-bit?
64.
64. How do we know? By the top, it says so right there. And also we're using R's instead of E's. That's another way to find out. Okay. So how could we make our code even simpler? Well, our code is pretty simple. String your number. But now we can start looking through. This is where take this code and put it into your debugger, because we got the new version of the debugger now called Gef, remember? So play with Gef and see what the name of the registers are that are taking it from the command line. Okay. So when you run your code, of course, we need to recompile it with -G. No, well, yeah. Let's try that. So this is compiling it to, what is it? This compiles it to a A.out, because I didn't say -O. So it just goes to A.out, and the G says, let's use it for the debugger. Okay. So I'll do ./G, and then I'm ready to run the debugger, right? G, db. Okay. And Gef has already started. First thing I want to do is set my breakpoint to main. And now we can start stepping through it. All right, there's my arg1, argc. And I can say IR. And look at all my registers. And see what things are going. Now, when I ran this, did I put a parameter on the command line? No. Nuts. I should do that so I can trace it through the debugger, right? So I can quit this. Try this again, and I'll use a number, I don't know, 555. So it'll be easy to see. Next, oops, run. Stops at the breakpoint. Now let's look at my registers.
So what we're doing right now is this related to the final
Typewriter program that we're doing in assembler. How do we do argv, argc in assembler?
Oh, okay.
That's the goal.
Sure.
And then in assembler, you know, doing it from C. Okay, yeah, that makes sense. But how does it work in assembler? There's a couple of things. And then for the final, I'm also going to add a couple of things from the programming from the ground up. Yeah. There's some good questions in there. And I know you guys can go all into Google, copy the question. But I hope you take at least a second to read the answer, so it sticks in your brain a little bit longer than the class. Okay. Because why do you need assembler? I was talking to a fellow who has made hundreds of thousands of dollars as a consultant. And he says, they still teach assembler? And I said, yeah. So you can learn how to use things like Wireshark and the debugger. Because oh, yeah, that makes sense. Because they use his tools without thinking about it. But yeah, that's why they do assembler. Okay. That's why we're walking through this. Okay. All done. Whoops. Why do I get a signal? All right, let me add another flag in here. Is dash. Oh, this is a fantastic question on the final. What's that slash thing for? What does that do?
Escape.
It's an escape slash line continuation character. This is in all programming languages I've touched. There have been that are on Unix, Linux. Okay. It just means make my long line. Don't put any spaces afterwards. Just hit slash enter. And then you can type in, you can continue on. And here I want the dash S. Of course. Now it's reduced even more. We've got an even smaller section of code here. Now, you all have your Chat GPT. You're ready to rock and roll, right? Go ahead and jump on Chat GPT and say Linux, MASM, and then ask specifically registers used for argv, argc.
They're down.
What?
So they're down. ChatGPT.
They are?
They've been down for a couple, like noon-ish, one somewhere around there.
I wonder why. Has anybody been following the news?
Yeah.
The news is Sam Altman got kicked out of OpenAI, basically without any warning. And he's the guy that started the company. So guess what? The CEO of Microsoft said, come work for us. And all the top lieutenants of OpenAI are saying, okay, we'll follow you. And this is, I don't want to get into big political debates on this, but basically the short and sweet of this is Sam Altman sees generalized artificial intelligence as the new printing press. In other words, mass dissemination of knowledge. And he wants to hit the accelerator and say, let's get this out there now. Let's go full bore and do real AGI. Okay. Well, the board said, no, wait. Well, who's on the board? People with deep ties to Washington and policy wonks that are scared of AI. So they said, out you go. And I don't think the board realized the ramifications that this is happening. But all I've got to say is buy stock in Microsoft. We'll never get rich like he will, but we can at least eat the emperor's grain and make a little money on the side. But don't bet anything on Microsoft that if it takes meat off the table, don't do it. Okay. This is not a sure bet. Okay. But I've been following it kind of closely, I've been trying to figure out some of the root causes of what happened. And I think it was just a philosophical difference because the board is thinking AGI and Terminator and Skynet. Okay. Now, you can take that for all the intent. You can argue any way you want about this. But current AI implementations, even the really good ones, are very good at one thing. They're great. Like if you train it all on medical, it's going to give you some really good medical advice because it's all medical. And you've been playing with, hey, it generates some pretty good code, doesn't it? Maybe. It generates code you got to spend a lot more time in the debugger with. That I do agree with. So is it better to use ChatGPT and get your assignments done? You copy it and you just paste it, but you don't know what it does. There's going to come a time where you're going to have to debug something and you won't have a clue of what you're looking at, but you still have to debug it. I speaketh from experience. It's the real world. Okay. So, all right. Now, what I want to do is this is Intel no syntax. Yeah. They still do that. Okay. All right. This is just walking through the debugger. Okay. But I was hoping we could use ChatGPT. Does not surprise me that they're down. The other parts that we'll be doing in, hold on a second here, for our final is and then what I will do once we get through, maybe after Thanksgiving, the last couple of nights, what I will do is show you how this stuff applies to you in the sense of debugging. Has anybody ever debugged a physical device like a camera or a clock, an IoT type of device? We'll be doing something like that. Well, we won't be debugging it per se, but we'll be learning how to connect to it and what you're looking at and how primitive it is that these tools still work. And anyway, that will be another thing we'll be doing. It should take a while to load. I'd like to have you walk out of this knowing how to apply some basic debugging and troubleshooting, because every senior technologist I have talked to over the past 5 years, or even longer than that, teaching troubleshooting is hard. Some people get it and some people don't. And every CIO I've talked to, they say the same thing. It came up in our IT advisory committee. I said, how do you teach troubleshooting? I have found one thing to correlate it to. If your entire life has been this, growing up, you might have more trouble troubleshooting. But if you've built things with your hands, woodworking, welding, construction, mechanics, machining, you know, the Legos, the idea of building things and breaking them down, building and breaking them down, that seems to be a prerequisite to learn how to troubleshoot. Is here it is. Now I want to make it again, so I have to break it down. And if you were like me, you took things apart, but you didn't always get them back together. And there was a old saying that said, knowledge comes from taking things apart. Wisdom comes from putting them back together. Yeah, take that for what it's worth. Okay. All right, let me find my book here. That's taking forever to load. There it is. That'll work. This is the other book I gave you. And what I'd like to do is these questions at the end of the chapter, not all of them. Like 3 through 8, most likely. Does that work? No. Nuts. Okay. Let's see. It says I'm on page 4. Am I really on page 4? Okay. Let's see how close it gets. Back one. Rewrite the programs in this chapter to use command line arguments to specify the file name. And we have a friend on GitHub that wrote all the answers for us. What? The requirement will be MASM. But we'll just, how do we convert? Remember that tool I gave you, Intel to gas? It converts between the two formats. But does it work well? Yeah, that's a fun part. So this is kind of what the final, this is kind of how I want to structure the final, is it's not hard, but there's lots of little pieces to figure out. Okay. So that's kind of the where the goal will be. So programming from the ground up, I'll give you the chapters because I want to make sure I don't add too much. Like I don't want to make this ridiculously impossible, but I want to make it attainable for those that are interested. And some folks are just here to survive the class and said, I don't care. I just want my D because D's get degrees. Well, sort of. I do believe it's now C's get degrees. Yeah. Some things they don't let you pass the 1.0, I don't think. And having 2 masters in a master's program, you have to keep your grade level at B or better, or you get dropped from the program. So if you ever get a master's program, take 1 class at a time. 1. Okay. All right. So this is what they're doing here is I actually really like this chapter 6 out of programming from the ground up, because they're using assembler to show you records and how to write a record and read a record. This concept of what is a record, what is a structure in C and C++ and Java is systemic to everything in databases. And you're going to write code that pushes and pulls data from a database. And reading, writing records, updating records. That's the way life is. Okay. So, and there's 1,000 references out there. So this is kind of what we'll be doing. So I will give you the specifics because I have like 5 rough drafts, but I wanted to get a feel from how you're doing. So do you think you could honestly answer these questions? Like, you know where to find the answer, right? Duh. But I would like to have you describe this stuff. Okay. In your own words. So even if you do rip off the answer, put it in your own voice. Okay. Then you have to synthesize it. Okay. Like, how would you describe a buffer to your grandma? Yeah, no idea. And most of you have had the joy and the privilege of trying to explain some of the technical details to your family and friend. And what do? Their eyes glass over and they just kind of, they don't even bother after a while. That's exactly what you're going to get when you try to explain complexity to your manager. So the better you are at that, the better it helps your long-term survival in the workforce. Okay. Okay. So let's go back to one that's easy here. Now, the nice thing about the programming from the ground up is that they're not using any header files. Okay. They're not using in stdio. They're using an actual interrupt, but this is all 32-bit stuff. Okay. So this is all 32. So when you exit, it just quits. Okay. It's using 80, quit, and then you type in echo $question to get your answer. So would we like to change that to make it look nicer using syscall and 64-bit? There will be a lot of opportunity for you to make this better. Okay. I get it. I'm getting a good feel of where we're going now. Okay. Now there is a tool I want to mention. Go ahead and hit this website, ANTLR. There we go. You don't want that one. I would like to have you do a shared library, but I'll have to think about that for a minute. Can somebody tell me what this is? Take a shot? As computer science majors, you will write a compiler. And what's a compiler do? This is a tool that allows you to take Java and convert it to C at the human readable level. Is it perfect? No, but it's been around a long time. The other sweet spot for this is domain specific languages. I can show you on the Linux OS 5 or 6 different shells that all have a different programming type of construct to it. This is how it's generated. This is something that you'll get to in your upper division 4-year school, maybe, depending on where you go. But it parses formal languages. Okay. So this is something that's very interesting. I used it only cursory when I had to move from one language to another. It was a good rough first go, but it still required a lot of hand work. But that first go really sped things up. Okay. So that's what Antler is. Can you use Antler to go from assembler to C? Maybe. C to C++, C++ to C. Yeah, that's a little more usable. But its sweet spot is where you define a grammar and then it creates a language for you that you can then take as a very specific programming language. Okay. All right. You all understand functions now. I can take that to the bank, right? You're all going to pass that interview question. Define a function for me. Okay. That's chapter 4. And its questions are, these are helpful questions. What are primitives? What are calling conventions? What's a stack? What's push L and pop L? What do they do? Okay. As you go through and answer these, if you're going to do it the old school way, like I would probably do, is that I would read the questions before I'd read the chapter. And then when you read the chapter, you kind of highlight where the questions are. And then you can say, oh, that's the answer. And then you can go back. Okay. But this book is very, the earlier chapters build. So if you start at chapter 3, which is where I'm going to assign the homework, it would be helpful to go back to chapter 1 and 2 and get a feel for his voicing. Okay. All right. I was hoping we could use ChatGPT tonight, but bummer. Let's see if I can get on. Anybody else get on? Nobody? Let's see what happens.
the app. Is it there's something?
Yeah, get notified when we're back. They're making it painful on purpose. So they'll be more willing to cough up that $20 a month. Planned obsolescence. Yeah, it's not working. Okay. Bummer. Now, I won't ask you, I may ask a few of the use the concepts, but it won't be exactly the same. It'll be something different. Okay. Typewriter that we did with Chat with a file name on the command line. And the questions from programming from the ground up with a few little things in there. And it'd be nice if you turned in your answers in NASM, but we'll go there. Okay. So on that note, bummer, I guess I could show you a little bit of what I want to do here. How many it's just a micro PC. Right? That's all it is, nothing fancy. Just a power cord, so it doesn't time out. This is a 9-pin serial port. This goes back a few years. Knowing how to use a serial port is required if you're going to work on switches and routers and networking. You have to know how to use the serial port. There are many different tools out there. You don't need a 9-pin like this. This little unit with a built-in 9-pin. If you look on the back of the computers underneath your desk, they don't have a 9-pin. They don't have a serial port. Now let me explain a little bit why this is important to you. Where did they all go? There they are. What am I looking at? How many have ever used a serial port? Anybody's used one? Aha! 2 people know what a serial port is. Yippee skippy. This is not SSH. This is not Telnet. This is serial. I am using this tool, GT Kerm, off of this computer that connects to this cable. That goes through a null modem cable that connects to the serial port on this little device. Just pretend this is a switch or a router. So I get this login, and I can log in as me. I can now do things on this box. There is no GUI. Everything has to be done in TTY, text only, no mouse. Okay. Your small IoT devices, almost all of them have some sort of serial device that you need to connect to do debugging. So if you're using a Raspberry Pi or Arduino or the real-time operating systems, which I can't remember the name of them all, they have tools that plug into a serial port, and then you can capture the output and see what's going on and fix it. Okay. Like our clocks in here, they're supposed to synchronize. They were down for almost all of COVID. Now, why did it take so long? Why? Well, one, it was pretty far down on the fix-it list. And two, it's some of the oldest stuff on campus. And people, how do you learn about something that's obsolete? Where do you go to learn how do you do something when the equipment is expired or dead? Okay. So this is a serial port. I'm going to show about this a little bit tonight in the Linux class, but basically this is how we used to do computing. The SCO Linux, the SCO Apple Lisa serial port. Okay, what's old is new. On that note, sorry, ChatGPT down. I used it today around 11:30, so it was working for me, and I was playing with the typewriter. I'm trying to figure out why it's got so many nulls in it when it writes. Okay, and I think I found it where it's when the buffers get allocated and it writes the entire buffer. It doesn't measure what the actual element is in the buffer. Okay. On that note, have fun, have a great Thanksgiving, come back 10 pounds heavier. And it's always a good vacation when you forget your passwords. And I'll get this written up and then we'll have it all available so you'll know what to expect over the last 4 sessions. Okay. So typewriter with ARC-V.
So is the typewriter thing going to be lab 9 or is that going to be?
It's going to be part of the final. So lab 9 will be the final. Lab 9 final lab.
Okay.
9.
What about the stuff we did last class?
That's typewriter.
Last class we did the Edlin thing.
Oh, that's what I meant. The Edlin, the editor.
Oh, that's gonna
Yeah, that typewriter / editor.
got it.
That's what we're trying to
But you're
do.
gonna make it accept input on the command line?
Yeah, where you put Edlin in the name of the file.
Uh-huh.
And then when you hit
Oh,
enter, it
okay.
opens a file, or it might be easier to start with an existing file. And
Yeah.
it puts stuff into it, saves and exits.
Okay, that's cool. That'll be an easy change to make because I pretty much did it. Well, I did do it already, but the file is hard coded. So
That's fine. The hard coded part is that's step 1.
Yeah,
And then
yeah.
step 2 is ARC-V it. And then the little steps you need in assembler to make it ARC-V.
okay, cool. I just found a really good resource for understanding the ARGs.
Oh, good.
How they get pushed onto the stack.
Oh, good.
Yeah, if you're looking for anything like that.
Yeah, send it
It's,
to me. Yeah.
It was on Stack Overflow, but I had to go find it on archive.org because
Oh, okay.
this giant forum with so much good information is just dead.
Yeah, well, that's usually what happens
Yeah.
because a whole new crop of people come in, and then they start reinventing the wheel.
Yeah.
Yeah, it's kind of how it goes. Yeah, send it to me. I'd love to see it.
So in the final week, you're gonna grade all the labs?
Yeah, the final lab would be lab 9.
Mhm.
It's basically the EdLin assignment that we used with Chat GPT
Right.
that takes a file name that opens, edits,
So,
saves.
so my missing lab, I can just bring it into you in the final week and you can.
Yeah, I'll go ahead and get them all done, and then you could submit them all with the same lab. Just let me know.
Okay,
Yeah,
thank you so much.
Yeah.
So good to see you.
no problem.
I wanted to ask about your Linux class.
Yeah.
I'm registered to take it next semester, but I was wondering, like, it seems like a lot of the kind of stuff you're covering in this class is also covered in that class. So I was wondering, like, I don't know, like, do I need to take it still? I think so, but I just wondered.
Well, it depends on what you want to do.
Okay, yeah. Well, I
Yeah.
don't really know yet, to be honest.
Yeah, you can't go wrong learning how to admin a box well,
Right.
because all the cloud stuff is all Linux,
Yeah.
and your routers and switches are a derivative of Linux.
Right.
And the serial port and VI, that stuff's everywhere. Yeah, unless you work for a school district, which is all Windows, which is a whole different thing, you know.
Right.
Yeah, but
Okay.
my recommendation is you can't go wrong with it, because the students that seem to get the good jobs are the ones that do really well in the Linux,
Yeah.
because it's so applicable to so many different things. Yeah.
Okay.
Security,
Right. Oh, yeah. I'll take it then.
yeah,
Yeah.
you'll have fun with it.
I'm sure. And this
Yeah.
class has been fun. So yeah.
Yeah. Yeah, you'll enjoy it.
Thank you.
You bet. Okay, let's try this. Mhm.
Do you know when you're gonna have the videos for the last few sessions on?
Do I know anything?
When you're gonna have the videos for the last few sessions on?
Yeah, I'll get them posted.
Okay.
Yeah, I've got them. I just need to put, they're almost there. Like this video tonight, I'll probably get posted tomorrow morning. Yeah, and then the other ones will get, they're in the queue, because I gotta wait for Zoom to process them. Then I gotta wait for Google to process them. But yeah, I'll get them there.
Alright,
No worries.
have a good day and happy Thanksgiving.
You too. Have fun. Eat lots.
I will.